Good afternoon, everyone. It gives me an immense pleasure to introduce today's speaker, Dr. Vishwanath P. Badiga sir. Badiga sir is an pure academician and a sports person and multifaceted person and human being, a very humble human being. Such a person was born on 22nd July 1966 in Sigli village, Lakshmeshwar, Gadag. Sir has done his basic primary schooling in Lakshmeshwar and with greatest achievements of that era. And he is also an sports person who represents kabaddi, wrestling, chess, running, swimming. He is such an multifaceted person. He has done his PUC at Government College Gulbarga and has scored 100 out of 100 in mathematics in 1982. Uh, Perhaps perhaps we done his BE degree at from electrical department with first class and has completed his masters in SJC Mysore with gate score in 1983 has done his BIM Tech in 1983 with the gate score 93 and apart from that he has also represented he worked as a research scholar in IISc Bangalore with regular research as a regular research scholar. Sir started working in BUB College as a lecturer, then went on working as a professor in BUB College again. Then he's also worked as an founder principal in SK Lakshmeshwar and a founder principal in PES Institute of Technology, Shimoga. Then after that, as he is a pure academician, he didn't want to. He wanted more to be focused on teaching. He came back to BUB and started working as a professor from 2012 till now. Apart from this, these areas of interest are Internet of Things, algorithms, deep learning and machine learning, big data, distributed cloud computing. Sir has produced three PhDs and apart from this, Sir has also received AICTE grant of 5 lakhs and 10 lakh for GIS and image processing and the project for AICTE project with image processing of 10 lakh in 1998. Sir is an sports oriented person who has won general championship in running, relay, long jump, kabaddi, kho swimming, and he also he won the district level medal in Dasra competition in swimming. Was also general championship in the KLCT Belgaum for 100 meters relay, then swimming, best stroke, swimming, kabaddi captain, football player. Was also general champion at IISc Bangalore for 100 meter swimming. He won a gold medal. And he is representing FIDE as international chess player. Won two times in FIDE international tournaments. Was a vice president for United Karnataka Chess Championship. Currently, he is a president of Dharwad District Chess Association, and he is also a wrestler. Apart from all these, sir is also a wrestler. So you cannot judge his dimensions. He is a very good person as well. Then, apart from this, sir has authored 10 international journals, all in the scope of Q1 to Q3, and 40 international conferences. So, with this, I would like to welcome our delighted speaker of the day, Dr. Vishwanath P. Balliga. Welcome, sir.
Thank you. Thank you, Mr. Girish. Girish was my student at BB College.
This was formal introduction. Informally, I am the student of him. And in 2005, sir has worked on lossless comprehension, to which company offered him a very good position in the company. in one multinational company. But as he is pure academician, he declined it. So company gave him an crystal chessboard.
You remember?
Yes, sir. Crystal chessboard worth lakhs together in 2005. Thank you, sir.
Thank you. And very important is I'm student of Ashok Rao sir. After seeing today I read the newspaper, Ashok Rao sir inaugurated the session. Yes, sir. Okay, and inaugurated this FPP. I'm very thankful to him. With his blessings, I continue. Okay, as a research person here. Uh, I'll start. Okay. The main topic that I will be discussing is nature inspired algorithms for AI, a case study of classification of medical images. See here, I may take a little bit time here. Nature inspired algorithms. Every day we observe so many algorithms. Okay, we try to say get inspiration from them. So inspired. Okay, how we can do that? How can we implement those algorithms using our own design and then run them? See how the results are. Many physics professors they spend a lot of time with the nature. They discuss with, they make a research in light, magnetism, electricity, and similarly, chemistry people also. Mathematics people, they are always there everywhere, even in Ganaka Yantra. Without maths, there is nothing. All these basic, science, chemistry, everybody need. Many people they call that mathematics is a must. That if the foundation is good, you can contribute a lot. Here we have nature inspired. See here, I will be very clear what many people may define it in a different manner. What I observe is nature inspired is nature. Nobody can beat the nature. First thing, scientists cannot manufacture even one grain of wheat. They say H2O. If I give two H and one O, they cannot create a water drop. They can say that it is there. They can say that heart is functioning, heart is beating. They cannot start the stopped heart once again. Nature has got a beautiful, algorithm. Mango tree gives the mango seed, and if you plant mango seed, you get the mango tree. It's a cycle. So nature inspired. I am talking about the life. There may be many definitions. When I talk nature inspired, the algorithms should be able to have something. Okay, extract the seed. From the seed, you should be able to get, say, whatever we give. We may give the movie. We may give the big data. All of us know that today we talk about so many big data using IoT data, industry data, this, that, huge data. No SQL, everything we use. Okay. However big it is, if you extract in the form of seed, that seed should be able to give the original data. That means a tree gives the seed, and that seed will take 4 years, 5 years, 6 years, 7 years to get a mango. Onion seed will take 3 months to become onion. Beans, if you plant short, within 40 days you get beans, right? Still coming to coriander seeds, within 1 week we get. Okay, see here, there is a difference between the time taken. I'm not talking about the low complexity algorithms. However, the algorithms are, let them be too big, we are least bothered. But nature inspired algorithms is give me anything, I will transform it, I'll make it so it's a seed, and then with the help of that seed, I'll be able to. Coming to the second part, AI, I'll come to the AI part later. A case study of classification of medical images. I have taken classification of medical images as a sample, not as a only hardcore. And I talk about nano structures also. We have published papers on that. But what is important is the case study. There also we look at what is that. Okay, classification. Today, if I give you a wheat seed, you can very easily say that it is a wheat seed. Rice, okay, it is a rice. If I give you any, there may be many seeds. If I give you orange seed, mosambi seed, apple seed, very easily we can predict that from the class of medical, I'm sorry, mosambi seed, we get only mosambis. From apple seed, we get apple seed. From almonds, we get almond tree. From cashew, we get cereal. None of them are, we cannot say that, oh, I am a cashew nut, but I am giving you a almonds. Nature will never tell that. Nature always works perfectly. I means I only. It defines the seer. Manufacturing on camera is easy for us. Manufacturing on small eye is not possible. We have to depend on the nature. So the title is very clear. Whenever I talk about the algorithms, they are nature-inspired algorithms for AI. AI is everywhere today. That is the main topic that even your FDP is concentrating. But I am also showing that how the scientists in the world, okay, can take better path, or they can take alternative thinking other than the one which we have been using convolution. Convolution is the heart of the function, heart of the classification, heart of the AI, or anything. Without convolution, we will never go to the deep learning algorithms. Training requires, classification requires, testing requires. Without convolution or downsampling, we never proceed. Okay. So I will talk about those what all the research gaps. Research gaps in deep learning. Okay. Keeping in mind the nature inspired algorithms. Nature inspired algorithms. First, I will run one program, small program. I hope all of you know. I am very sorry that would have tried, giving this. I hope since audience are very less, you are able to see them here. I hope so. On the projector, we could not connect this. I will run this. Okay. I don't tell you what is the program. I will not tell what is the program. Okay. Now, all of you are able to see this. There is a beautiful lady selected by IEEE standard. What is her name? Lena. Lena. Okay. It is called Lena. L-E-N. Lena. Most of you are already familiar with the image processing, right? All of you are computer science and you are teaching. Now I will just. What is this? Oh, it is not coming there. Is it visible here? It is not visible, right? It is visible very black, and there are some dots in the top. I will maximize that. Okay, actually, it will look very beautiful on the projector, but however it is, we are able to judge. See here now, everything is black here, but on the top corner, we have some bright, bright pixels. Okay, then I press again the anything here. See here, what has come? Lena has come back. We have done DCT, discrete cosine transform. We converted the Lena into hardly few coefficients here, okay, compressed. We are very familiar with the compression, but I have done PhD in compression only from Indian Institute of Science, Bangalore. But this is not the platform to discuss. These very few coefficients are sufficient to construct Lena back. That means our scientists have already done that. I am showing you some examples where original data, then take some transform, reconstruct them back. Right? Now, how this is done, I can run a small program and show you how DCT works. Why? This is one where I can show you why this is important is I will run this and you can see that. See, we have executed. There are some waves now. What we are doing is at different frequencies, okay, we are collecting the points. Okay, DCT is something that you must have already studied. DCT and inverse DCT, it is always possible. You have data, compress it, and even today, JPEG makes use of this DCT. JPEG, you store in the form of what is that? So these are the different frequencies that they make use of. The same thing I can show you by splitting. I don't know whether you are able to see them. Okay, it would have been better on the screen. Is whether the signals are visible? Signals are visible. We are taking in one cycle at different interval, maybe 8 points we consider. And then for vary the frequency, you will get frequency varied signals. I have taken around 8 signals with the frequency 1 hertz, 2 hertz, 3 hertz, and up to, and then at fixed intervals I am taking the points. Those points are stored such that, okay, you can use those them to reconstruct the data value. That is given by DCT people. Okay, he is the one who has found out. He is from India. Okay, let me show you if that is there. Okay. That is regarding DCT. Before I proceed further, there are many scientists who have given different ways. Different ways. One of them is, I think, mathematics professor was here. Here, sir. Sir, fast Fourier transform. What is FFT fast Fourier transform? It is nothing but the addition. It is nothing but the addition. It gives the sub frequencies, add them, you get the total. Suppose I have 1 to 9. The sum is 9 into 5, 45. Okay, 1 plus 2 plus 3 plus. I give some samples, it will be near to the 45. If I give all, it will be 45 by adding. What the Fourier gave is, he gave something that the summation of the signals from minus infinity to plus infinity, okay, by choosing the frequencies and the magnitude, you can find out the frequency components of the given data. Those frequency components will be very few, and then store them. Reconstruct the original data back. See, very powerful tool. Even today, we are making use of FFT rigorously. Why I am telling you is nature inspired has got the technique of transforming from one form to another, seed to tree, tree to seed. Okay, transform motion of the data, reverse back. Okay, so these are the few things which we can see. Okay, I think I can nail the PPTs. That's okay. I try to show that. I think it is visible. Okay, the sum of the signals will give us the resultant signal. Okay, so maybe we talk about Fourier transform later. I'll continue with this. Another important transform was wavelet transform. Many people have worked on wavelet. Okay, I will execute the program and then I'll come to the slides later. So this is the Lena image. Lena image. I'm taking the WT, that is wavelet transform of this. I'm taking to explain how the algorithms work, okay, which are similar to the nature. This is the original image. You can observe here, we have filtered low pass and the high pass. Low pass and the high pass. Okay, and then you can continue this row wise and column wise. See, first we compress like this, then we compress like this. We are getting. I don't know whether you are able to see this. Is it visible, sir?
Yes, sir.
Okay, good. Now, why I am talking about three transforms is all the three transforms: discrete cosine transform, Fourier transform, wavelet transform. There are many Laplace transform, Z transform, many are there. There is an inverse way of getting the original data back. See here, we are getting the data back. Please remember this because this property is lacking in deep learning. In deep learning, there is a research gap. What is that gap? Once we say, for example, downsample, once you make a convolution, you will not be able to get the data back. Okay, that is lost forever. We are taking only the filtered data, or you can say we call it them as features. We call them as features. Once we extract features, we will not make use of the remaining data. But in case of nature, it has got the ability to reconstruct from the seed. See, small seed, it becomes a tree. Small density coefficients, small number of density coefficients are capable of reconstructing the data back. Wavelets constructing the orthogonal property, we call them. Okay, and then fast Fourier transform, inverse fast Fourier transform. So why I am comparing is many people are saying that deep learning is a excellent one, excellent solution, excellent way. Everybody is talking about AI, but there are many people who have contributed something great to come to this level. We should not forget our forefathers. Today we talk about AI, machine learning, deep learning, everything, but core mathematicians, core physics, core chemistry, we cannot forget. Similarly, core basic scientists in computer science who have found out DCT, FFT, and WT, we should not forget because they are the great contributors which we can embed them into our deep learning layers. See here, we have something good we can make use of. So that is where the some research gap is there. We'll have to look into that so that the performance of the model that we design will be better, will give better result, better performance. Okay. Example I would like to show you before I proceed, or I will show you during the convolution. Okay, one more transform is there. How can you, without destroying all these FFT, DCT, WT, all look same once you take a transform. Human beings, we cannot, say that this is the seed of mango tree. We can very easily. We cannot say that this is the transform of Lena, this is the transform of Barbara, this is the transform of brain, this is the transform of kidney. We cannot tell. That disadvantage is overcome in spatial domain, which I will show you that program maybe after some time when I come to convolution. Now, all of us know that what is the beauty of this, AI. AI can be implemented in many areas. Many areas. Today, there is no area in which we cannot say that it cannot be implemented there. Especially the Gen AI, okay, generative AI, they will make use of even in textiles. Okay, oh, this is a new fashion. New fashion. Gen AI. Recently, while reading a paper, a newspaper, okay, I got one, article. Iron Lady of India, Indira Gandhi. Something question or asked, it has to generate another picture. Okay. Yeah, chat GPT, many people ask, put the questions. So one person put Iron Lady of India, Indira Gandhi. Some picture it wanted. So generative AI generated. Indira Gandhi is making the Iron Lady. Generative AI. How does it? Generative AI. So generative AI is something which is very interesting, but we should be able to filter it. We human beings have better knowledge and capacity of taking a decision. Okay, Iron Lady of India. So we should not. You are laughing. That means you know why you are laughing. Okay, that is the correct answer. Now, this AI, when we are making use of, whenever we use, we have to be careful. It is like a sword. It is like a sword. I have given a simple example. Okay, so these are all. Main focus is, can we reach 100%? Accuracy in classification. Many of us say that I got 99%, 99.8%, 100%. People who are, say, capable of designing a model and then getting a 100% result is perfectly all right, according to me. What I say is, somebody says that it is overfit or something like that. No. If your model is giving 100%, classification, that is absolutely fine. Okay. These are all the definitions, okay, which we talk about, what is the machine learning, this, that. Okay, simple things, definitions which you are already knowing. Okay, he says machines, they learn by experience, this, that. Simple things which we don't want to, okay. Coming to the deep learning model, we have called it deep learning because of the many layers that we go across. Okay, so as earlier, a few minutes back, I said, what is the disadvantage of convolution? We are getting good result, but what is the disadvantage? Okay, what strength it doesn't have, that we have to look at. So basically, we use it for recognizing complex objects or complex scenes or medical images. I am taking the example of medical image classification. Okay, these are the basic things. Deep learning, machine learning, AI. We know we have been doing for the past so many years. Okay, we have come across many algorithms, and today we have reached certain models. Okay, when competition is there, some models have won. There are different learning algorithms. Okay, supervised, unsupervised, and so on. When coming to the medical images, we have to have the doctors. They have to label. We are not the experts. So either we go to Kaggle or we go to KLE hospital or any other hospital, consult doctors and have a data set. Without doctors or classified images, we cannot train the model. So basically, we talk about traditional programming. All of us know that we have traditional programming. We give the input, write the program, get the output. We have been doing that. But in case of deep learning, machine learning, what we do, we give